The James Webb Space Telescope has been called humanity's greatest eye on the cosmos. Launched into the darkness beyond the reach of Earth's atmosphere, it was designed to answer some of the biggest questions about the origins of the universe. But nobody expected it to stumble upon something so baffling, so unexplainable, that even the brightest minds at NASA are struggling for answers. A strange signal, one that defies everything we thought we knew about space, has now been detected, and the implications could be far bigger than anyone dares to admit. In a mission that already made headlines for its stunning images of distant galaxies and infant stars, the James Webb Telescope has now captured something different. Something that isn't a planet, isn't a star, and isn't anything we've catalogued before. It appeared like a whisper from the void, a delicate but persistent anomaly that refuses to fit into any known pattern. Scientists across the globe are now locked in an urgent quest to decode the message hidden in this mysterious space signal. This detection didn't come from one of Webb's dazzling full-color images. It wasn't some brilliant nebula or distant supernova lighting up the darkness. Instead, it came from Webb's deep spectroscopic data, an intricate fingerprint of light that revealed a signature unlike anything previously recorded. The excitement in the scientific community is palpable, but so is the confusion. What kind of object, or force, could send such a precise, repeating signal across unimaginable distances? As soon as the James Webb Telescope's detection was confirmed, the theories began pouring in. Could it be a rogue star behaving strangely? Perhaps a hidden black hole emitting some unknown form of radiation? Or, more provocatively, could it be something artificial? A signal not born from chaotic natural processes, but crafted by intelligence. The very idea seems lifted from the pages of science fiction, yet here it is, recorded in Webb's flawless instruments, demanding an explanation. NASA scientists have been cautious in their public statements, careful not to fuel wild speculation. Yet behind closed doors, sources report that there is genuine puzzlement, and even a hint of excitement. Several researchers involved with the James Webb discovery have admitted that the signal exhibits patterns and properties not easily explained by natural astrophysical processes. While it's far too early to shout, "alien contact," the mere fact that serious scientists are entertaining the possibility speaks volumes. The James Webb Telescope was not explicitly built to search for extraterrestrial life, but its ability to peer deeper into the fabric of the universe than any instrument before it makes it the perfect tool for uncovering the unexpected. And now, it has delivered exactly that. A cosmic mystery that challenges our assumptions and stretches the limits of our understanding. The strange signal was picked up during a routine scan of a distant star system located nearly 1 billion light-years away. It was supposed to be a standard observation, a calibration test, even. Instead, the data revealed a tightly packed burst of energy that repeated at intervals too precise to be attributed to cosmic noise or random fluctuations. In the field of astrophysics, precision often hints at intention, and intention suggests design. Is it a natural phenomenon we simply haven't discovered yet? Some new kind of star or particle interaction? Or is it the echo of something far more profound, perhaps even a deliberate attempt to communicate across the vast ocean of space? These are the questions now swirling through the minds of scientists, astronomers, and curious thinkers alike. What makes this discovery even more astonishing is that the James Webb Telescope is still in its early mission phases. If such a strange and potentially groundbreaking detection can occur this early, what else might be lurking out there, waiting to be found? Could this be the first of many signals, a breadcrumb trail leading us to a deeper understanding of the cosmos, and perhaps even our place within it? NASA has confirmed that a full investigation is underway. New observations have been scheduled, and some of the best minds in astrophysics are dedicating their efforts to unraveling the enigma. But for now, the strange signal remains exactly that: strange, unexplained, and profoundly intriguing. As we journey deeper into this astonishing discovery, the story only becomes more complex, more controversial, and more thrilling. The James Webb Telescope has already revolutionized our view of the universe, but with this mysterious space signal, it might just be rewriting the very definition of discovery itself. The James Webb Space Telescope, humanity's ultimate eye. Long before the James Webb Space Telescope captured a strange and baffling signal from deep space, it was already considered one of humanity's most ambitious scientific achievements. Designed to be the successor to the legendary Hubble Space Telescope, JWST represented a bold leap forward, both in terms of technology and in the scale of humanity's cosmic ambitions. It was not just another observatory. It was built to answer some of the most profound questions about the universe, from the birth of the first galaxies to the possibility of alien life beyond Earth. The story of the James Webb Space Telescope began in the late 1990s when NASA, along with the European Space Agency and the Canadian Space Agency, envisioned a next-generation observatory that could see farther and clearer than anything that had come before. Hubble had changed the world with its stunning images and groundbreaking discoveries, but it had its limitations. Scientists knew that to truly peer into the earliest moments after the Big Bang, they would need to design something revolutionary. That vision ultimately took shape as the James Webb Space Telescope, named after the NASA administrator who played a crucial role in the Apollo missions. The most significant difference between JWST and Hubble lies in how they view the universe. Hubble primarily operates in the visible and ultraviolet parts of the spectrum, capturing breathtaking images of stars, galaxies, and nebulae. But the James Webb Space Telescope was designed to see in the infrared spectrum. This means it can detect heat signatures, allowing it to peer through thick clouds of dust and gas that obscure the view of traditional telescopes. In the universe's earliest days, light from the first stars and galaxies was stretched by the expansion of space, shifting into the infrared range. By observing in infrared, JWST essentially acts as a time machine, allowing us to glimpse the universe as it was over 13 billion years ago. The mirror of the James Webb Space Telescope is another marvel of engineering. Measuring an enormous 6.5 meters in diameter, it is nearly 3 times larger than Hubble's primary mirror. Made from lightweight beryllium and coated with a layer of gold just a few hundred atoms thick, the mirror had to be folded up to fit into the Ariane 5 rocket that carried it into space. Once deployed, the mirror unfolded with perfect precision, a ballet of engineering that took weeks to complete. Every segment had to align to nanometer precision to form a single, flawless surface capable of focusing the faintest light from the most distant corners of the cosmos. Positioned nearly 1 million miles from Earth at a location known as the Second Lagrange Point, or L2, the James Webb Space Telescope enjoys a stable and unobstructed view of the universe. Unlike Hubble, which orbits relatively close to Earth and can be serviced by astronauts, JWST is far beyond the reach of any repair mission. This made its deployment one of the most nerve-wracking operations in the history of space exploration. Every mechanism had to work perfectly. Failure at any stage could have rendered the $10 billion observatory useless. Yet, against the odds, everything went according to plan, and Webb came alive, opening a new chapter in astronomy. Even before the detection of the strange signal that now grips the world's attention, JWST had already delivered a cascade of stunning discoveries. In its first year alone, the telescope captured images of ancient galaxies that appeared surprisingly mature, challenging current models of cosmic evolution. It detected carbon dioxide in the atmosphere of an exoplanet for the first time, a critical milestone in the search for habitable worlds beyond our solar system. It revealed the complex chemistry of star-forming regions with unprecedented clarity, showing scientists how stars and planets are born amid swirling clouds of dust and gas. In one breathtaking image, Webb unveiled the cosmic cliffs, a region at the edge of a giant star-forming nursery, looking like towering mountains lit by the glow of newborn stars. The sheer sensitivity of the James Webb Space Telescope is almost difficult to comprehend. It can detect the heat signature of a bumblebee at the distance of the Moon. Its instruments are so finely tuned that they must be kept colder than 370 degrees Fahrenheit, shielded by a multi-layer sunshield the size of a tennis court. This sunshield protects the delicate instruments from the warmth of the Sun, Earth, and even the telescope itself, allowing JWST to capture the faintest whispers of heat and light traveling across the universe. Beyond the images that dazzled the public, Webb has been quietly collecting mountains of data, scanning exoplanet atmospheres, mapping distant galaxies, and peering into the heart of star clusters. Scientists have only just begun to scratch the surface of what this observatory can reveal. Every observation has the potential to rewrite textbooks and challenge long-held assumptions about how the universe works. When the strange signal was detected, it was against this backdrop of extraordinary scientific progress. James Webb had already proven its ability to change the way we see the cosmos. But this discovery was something different. It was not just a new galaxy or a stunning nebula. It was an anomaly, a fingerprint in the data that resisted easy explanation. The same precision that allowed Webb to unveil ancient galaxies now revealed something unexpected, something that defied classification. The James Webb Space Telescope stands as a testament to what humanity can achieve when ambition meets ingenuity. It is the culmination of decades of work, collaboration across nations, and the dreams of thousands of scientists and engineers. With this mysterious space signal, JWST has not just expanded our view of the universe, it has reminded us that for all our advancements, the cosmos still holds secrets we have yet to understand. As scientists rush to decode the new discovery, one thing is certain: the age of cosmic mystery is far from over, and the James Webb Telescope is just getting started. The strange signal, what exactly was detected? In the vast stillness of deep space, amid a silent sea of distant stars and ancient galaxies, something unusual stirred. It began as a whisper, a faint distortion in the streams of data pouring in from the James Webb Space Telescope. At first, no one noticed. With thousands of terabytes of cosmic information captured daily, it is easy for a slight anomaly to slip through unnoticed. But within days, careful analysis revealed something extraordinary. Hidden in the observations was a signal that simply didn't belong, a pattern that broke the expected noise of the universe. It was a message written in frequencies and rhythms never before recorded. The timeline of the detection is as fascinating as the signal itself. In late February of this year, the James Webb Telescope was conducting a deep sky survey of a region near a distant galaxy cluster, part of a broader mission to understand the formation of early galaxies. The telescope's near-infrared spectrograph, one of its most powerful instruments, was busy dissecting the light from these ancient formations, splitting it into a rainbow of data that could tell scientists what elements were present and how far back in time they were looking. Yet, among the expected results, a strange, persistent signal kept appearing. Initially, the data team thought it might be an artifact, an error introduced by the instruments themselves. After all, space-based observatories are finely tuned, but even the best can experience glitches. Redundant systems are in place to catch such errors, and Webb is no exception. However, when scientists cross-referenced the data using multiple instruments aboard the James Webb Space Telescope, they found the same anomaly repeated with startling consistency. It was not a mistake. The signal was real, and it was coming from a point in deep space where no known object should have been emitting anything detectable. What makes this discovery even more intriguing is how the James Webb Telescope picked it up. Unlike visible light telescopes, JWST operates in the infrared, allowing it to capture the faintest emissions from some of the coldest and most distant objects in the universe. The near-infrared spectrograph and the mid-infrared instrument work together like a cosmic detective team, reading the heat signatures and molecular fingerprints of distant phenomena. In this case, they detected a repeated burst of energy at regular intervals. The signal appeared in the infrared spectrum but carried harmonics and sidebands, complex features not typically associated with naturally occurring cosmic bodies. One of the first questions researchers asked was whether the signal could be a form of pulsar emission. Pulsars are highly magnetized, rotating neutron stars that emit beams of electromagnetic radiation from their magnetic poles. As they spin, these beams sweep across space, creating a lighthouse-like effect. Pulsars are known for their clockwork regularity, and in many ways, they might seem a fitting explanation for a repeating signal. However, the frequency range of this anomaly did not match any known pulsar. Furthermore, the energy profile of the signal, its structure, and its spectral spread were unlike anything observed from pulsars, magnetars, or even exotic stars. Another early theory considered the possibility of an undiscovered type of black hole behavior. Some black holes, particularly those at the centers of galaxies, emit bursts of energy as they consume surrounding matter. However, these emissions are chaotic, erratic, and usually in higher energy ranges like X-rays and gamma rays, not in the steady, patterned infrared bursts observed by JWST. Moreover, black hole emissions typically create noise across multiple wavelengths, not the sharply defined, narrow band emission recorded here. Scientists also pondered whether the signal could originate from a rogue planet, a free-floating world not bound to any star. While it is true that rogue planets can sometimes emit faint infrared radiation due to residual heat, their signatures are diffuse, lacking the tight repetition and energy modulation seen in this signal. A rogue planet could not account for the precision. The mystery deepened with every passing analysis. What makes the strange signal even more compelling is its non-random nature. The cosmos, while rich in structure, is fundamentally noisy. Randomness is the rule, not the exception, particularly when it comes to natural radio and infrared emissions. Yet this anomaly showed characteristics of encoding, a deliberate sequence of peaks and troughs separated by consistent intervals. The timing of the signal bursts followed a pattern more akin to engineered transmissions than to anything nature typically produces. It was not a steady hum, nor a chaotic roar. It was a whisper repeated with methodical certainty, as if it carried information within its subtle fluctuations. Adding to the puzzle was the apparent lack of a visible source. High-resolution imaging from the James Webb Space Telescope's near-infrared camera showed no obvious object at the location of the signal. No star, no galaxy, no black hole. Just a patch of darkness against the tapestry of the cosmos. Yet from that darkness came an unmistakable signature. Whatever was generating the signal was either too faint to detect visually or cloaked in a way that made it invisible to even Webb's powerful gaze. As word of the discovery spread within scientific circles, theories grew increasingly imaginative. Some speculated that the signal could be the result of a natural phenomenon never before observed, perhaps a new class of cosmic object. Others wondered if it could be a techno-signature, evidence of advanced technology emitting detectable energy across interstellar distances. The term techno-signature has gained prominence in recent years, referring to any measurable attribute that would indicate the presence of intelligent life, such as radio signals, laser flashes, or engineered structures. To assess the strangeness of the signal, scientists applied statistical models comparing it to known cosmic background emissions. The results were shocking. The probability that the signal was the result of random cosmic noise was less than 1 in a billion. Such odds suggested a profound departure from the norm. If the signal was natural, it was unlike anything catalogued in decades of astronomical observations. Complicating the matter further was the detection of secondary features in the signal. Minor fluctuations hinted at a layered structure, as if multiple elements were superimposed on the main transmission. In communications theory, layering is a hallmark of complexity, often associated with the deliberate encoding of information. While scientists caution against leaping to conclusions, the layered structure of the signal presents a tantalizing clue that whatever is out there might not be entirely random. Even the direction of the signal's origin adds to the mystery. It appears to come from an area of space located well beyond the boundaries of our galaxy, possibly from a region between galactic clusters known as intergalactic voids. These vast expanses are thought to be largely empty, sparsely populated with only the occasional rogue star or drifting cloud of gas. Finding a structured signal emanating from such a barren region defies expectation and raises profound questions about the nature of the cosmos. As scientists work feverishly to understand this bizarre detection, one thing is clear. The James Webb Space Telescope has delivered more than just another scientific triumph. It has opened a doorway to a mystery that challenges the boundaries of human understanding. The strange signal, whatever its origin, demands that we reconsider what is possible in the vast, uncharted wilderness of space. Whether it leads to a new branch of astrophysics or the first evidence of an intelligence beyond Earth, the journey to uncover its secrets has only just begun. There is also a growing sense that if this signal does turn out to have a non-natural origin, it could reshape not just science but every facet of human life. Philosophers, theologians, sociologists, and political leaders would all be drawn into the conversation. What would it mean for our sense of identity, for our religions, for our political systems, to know beyond doubt that we are not alone? These are questions that cannot yet be answered, but already they linger at the edges of the unfolding story, casting long shadows into the future. Some scientists have drawn parallels between this moment and the early days of the Copernican revolution, when the first cracks appeared in the old, Earth-centered view of the cosmos. Just as the discovery that Earth orbits the Sun upended centuries of belief and forced a complete reimagining of humanity's place in the universe, so too could the confirmation of an ancient alien artifact, or an ongoing extraterrestrial beacon, profoundly alter our understanding of reality. At the same time, there remains the ever-present possibility that this will turn out to be something entirely natural but poorly understood. Some unknown type of astrophysical process, some bizarre quantum effect, or an interaction between interstellar matter and exotic particles could yet explain the data. Scientists are well aware of how easy it is to see intention where there is only coincidence, to project intelligence onto patterns born of random chance. This is why the official stance remains one of cautious investigation. New observational campaigns are already underway, with additional instruments being tasked to verify and expand upon the James Webb findings. Independent teams from other countries and space agencies are reviewing the data, applying their own models and analyses. The goal is simple but monumental: to find the truth, whatever it may be, and to do so with the utmost rigor. In the meantime, the whispers continue. In quiet conversations, scientists allow themselves to wonder whether they are standing at the edge of one of history's greatest discoveries. Whether they are hearing, faint and distant, the first echoes of a story far older and stranger than anything humanity has ever imagined. And whether, just maybe, the universe has been waiting all along for someone to finally listen. When space gave us baffling signals before, the strange signal detected by the James Webb Space Telescope is not the first time humanity has found itself puzzled by mysterious phenomena in the cosmos. Throughout history, the universe has sent us signals we could not immediately explain, and each of these events has taught us important lessons about the limits of our knowledge, the dangers of rushing to conclusions, and the enduring allure of cosmic mysteries. Among the most famous are the WOW signal, the discovery of fast radio bursts, and the baffling behavior of Tabby's star. Each case offers a window into how science approaches the unknown, and each carries lessons that now echo in the investigation of the James Webb anomaly. The WOW signal remains one of the most iconic unsolved mysteries in the search for extraterrestrial intelligence. On a warm August night in 1977, astronomer Jerry Emmon was reviewing data collected by the Big Ear radio telescope at Ohio State University when he noticed a startling anomaly. It was a strong, narrowband radio signal that stood out dramatically from the background noise. Its intensity was so striking that Emmon circled the printout and scribbled the word "wow" next to it, forever branding the detection with a name that captures the awe it inspired. The wow signal was precisely the kind of event SETI researchers had been hoping for. It appeared at a frequency near the hydrogen line, considered by many to be a universal constant likely to be used for interstellar communication. It was strong, clean, and lasted for a full 72 seconds, the exact amount of time the Big Ear telescope could observe a particular region of the sky due to Earth's rotation. Yet despite repeated attempts to locate the signal again, it was never detected a second time. The wow signal remains a singular event, a whisper from the stars that came and went, leaving behind only questions. Scientists have proposed numerous explanations over the years, ranging from reflections off space debris to rare astronomical phenomena, but none have been definitively proven. To this day, it stands as a humbling reminder that not every mystery yields its secrets easily. Fast radio bursts, or FRBs, represent a more recent and equally perplexing chapter in the history of strange cosmic signals. The first FRB was discovered in 2007 by Duncan Lorimer and his student David Narkovich, using archived data from the Parkes Observatory in Australia. These bursts are incredibly brief, lasting just milliseconds, but they are astonishingly powerful. In the time it takes to blink an eye, an FRB can release more energy than the sun emits in an entire day. For years, FRBs were a complete mystery. Their short duration made them incredibly difficult to study, and their origins were unknown. Theories ranged from colliding neutron stars to magnetar outbursts to, inevitably, speculative suggestions of alien civilizations. The discovery of repeating FRBs added a new layer of intrigue. If some FRBs repeated, could they be intentional signals rather than random events? Over time, evidence mounted that at least some FRBs were natural in origin, likely tied to extreme magnetic activity in neutron stars. Yet even now, some FRBs remain unexplained. The irregularities, the variations between different bursts, and the occasional periodicity continue to challenge scientists and fuel ongoing research. FRBs taught the scientific community an important lesson, that patience, persistence, and the accumulation of data are critical when confronting the unknown. Initial excitement must be tempered by rigorous analysis, and even then, the universe may still surprise us with phenomena we had never previously imagined. In many ways, the approach now being taken with the James Webb signal reflects these lessons, ensuring that excitement does not overshadow caution. Tabby's star, officially known as KIC 8,462,852, offered yet another cosmic mystery that captivated the public and scientific world alike. Discovered during the Kepler mission's search for exoplanets, Tabby's star displayed an unprecedented and highly irregular pattern of dimming. Unlike the smooth, predictable dips caused by orbiting planets, the light from Tabby's star would dim dramatically and unpredictably, sometimes losing up to 22% of its brightness for days or even weeks at a time. At first, the leading theories included natural causes such as clouds of dust or swarms of comets passing in front of the star. However, none of these explanations fully accounted for the strange patterns observed. This opened the door for more speculative ideas, including the possibility that the dimming was caused by a massive alien megastructure, perhaps a partially completed Dyson sphere constructed to harvest energy from the star. The idea captured the public imagination and brought significant attention to the study of Tabby's star. Further observations and analyses eventually suggested that large amounts of dust were the most plausible explanation, with the light blocking being more effective at some wavelengths than others, as would be expected from fine particulate matter. While the alien megastructure theory faded into the background, the fascination with Tabby's star remained, a testament to the powerful intersection of mystery, science, and imagination. It also reinforced the importance of exhaustive natural explanations before leaping to extraordinary conclusions. Each of these historical mysteries offers vital context for the James Webb discovery. The wow signal reminds us that some anomalies may never be fully explained but still offer valuable insights into the universe's unpredictability. Fast radio bursts demonstrate that phenomena once thought mysterious can eventually be understood through diligent study and technological advancement. Tabby's star shows how public excitement can be both a driving force for research and a cautionary tale about the risks of premature speculation. The strange signal captured by the James Webb Space Telescope sits at the intersection of these lessons. It is strong, consistent, and stubbornly resistant to easy categorization. It could eventually reveal itself to be a new type of natural phenomenon, an exotic cosmic event unlike anything seen before. Or it might, just might, represent something truly extraordinary, a message or relic from a civilization far older and more advanced than ours. Either way, the universe has once again reminded us that it still holds secrets far beyond our current understanding, and that every discovery, whether easily explained or endlessly puzzling, brings us one step closer to grasping the full grandeur of the cosmos. As the investigation into the James Webb strange signal continues, scientists carry with them the hard-earned wisdom of past mysteries. They know that the truth, when it finally emerges, will be even more fascinating than speculation. Whether the strange signal is a new wonder of nature or the first undeniable evidence of intelligent life beyond Earth, it already stands as a beacon, calling humanity deeper into the unknown, and inviting us to keep asking questions, to keep listening, and to keep reaching for the stars. The future of this discovery, what happens next? The discovery of the strange signal by the James Webb Space Telescope has set into motion a flurry of scientific activity unlike anything seen in recent years. Behind the scenes, teams are working around the clock, coordinating across continents to ensure that no detail is missed. The future of this discovery promises to be as thrilling as the initial revelation, with an unprecedented level of collaboration and exploration now unfolding. The James Webb team, aware of the potential significance of their find, has already initiated an intensive series of follow-up observations. Scheduled telescope time is being reallocated to allow for deeper, more targeted scans of the region where the signal originated. Instruments on board JWST, including the near-infrared spectrograph and the mid-infrared instrument, are being pushed to their limits to capture higher resolution data. By observing the anomaly across multiple wavelengths and over extended periods, scientists hope to determine whether the signal's characteristics change over time, and whether any accompanying phenomena, such as faint light emissions or gravitational disturbances, can be detected. The response has not been confined to NASA or even the James Webb team alone. International collaborations are quickly forming to study the anomaly from multiple angles. Observatories across the globe, from the European Southern Observatory in Chile to the Subaru Telescope in Hawaii, are coordinating efforts to gather complementary data. Radio observatories, such as the Square Kilometre Array under development in South Africa and Australia, are being consulted to check for any associated radio emissions that might align with the strange infrared signal. This global scientific mobilization underscores the magnitude of what is at stake. If the signal is confirmed to be truly anomalous, and even more so if it hints at an artificial origin, then it would represent a discovery that belongs to all of humanity, not just to a single nation or agency. At the same time, proposals are already being drafted for new space missions dedicated to investigating similar anomalies. Some scientists are advocating for specialized probes that could be launched to study regions of space where unusual signals have been detected, equipped with instruments specifically tuned to pick up non-natural emissions across the electromagnetic spectrum. There is also talk of expanding current SETI initiatives to include targeted searches based on the James Webb findings. If this signal turns out to be part of a broader pattern, we may be on the verge of a new era in space exploration, one focused not just on finding habitable planets or mapping galaxies, but on identifying and studying signs of cosmic engineering or communication. In the coming months, the world can expect a steady trickle of updates as new data is analyzed and interpreted. NASA has indicated that a full technical paper will be published once the initial round of verification is complete. This paper will likely detail the signal's properties in exhaustive technical terms, allowing independent researchers to review and critique the findings. Simultaneously, public briefings are expected to continue, though they will likely remain cautious in tone until every natural explanation has been thoroughly explored and ruled out. If the anomaly persists and continues to defy conventional astrophysical models, we could see even more dramatic announcements within the next year. There is a growing sense among those close to the project that the next 12 to 18 months could be pivotal, not just for this particular discovery but for the future of humanity's quest to understand its place in the universe. The strange signal detected by the James Webb Space Telescope has already changed the course of space science. It has reignited a sense of wonder and curiosity, drawing scientists, philosophers, and dreamers alike into its mystery. Whatever the final explanation turns out to be, whether a new, exotic natural phenomenon or the first undeniable whisper from an ancient or distant intelligence, the future of this discovery promises to be one of the most extraordinary journeys humanity has ever undertaken. Are we ready for what's out there? The strange signal detected by the James Webb Space Telescope has reignited a timeless question, one that cuts to the very core of human curiosity. In a universe so vast that it defies comprehension, where billions of galaxies swirl through an endless void, humanity has always wondered whether we are truly alone. Every new discovery brings us closer to confronting that question head-on, and now, perhaps for the first time, we find ourselves standing at the threshold of an answer. Scientifically, we have come a long way. Our telescopes peer deeper into space than ever before. Our instruments can detect the faintest whispers from the most distant corners of the cosmos. Our models of planetary systems, stellar evolution, and cosmic structure have grown staggeringly complex. Yet for all our technological achievements, the truth is that we remain at the beginning of understanding the universe's deeper mysteries. The James Webb discovery reminds us that the unknown still vastly outweighs the known. Socially and philosophically, the question is even more profound. Are we prepared for true alien contact? How would societies around the world react if undeniable evidence of extraterrestrial intelligence emerged? Would it unite us or divide us further? Would it shatter belief systems or inspire new ones? These are questions that science alone cannot answer. They reach into the realms of culture, identity, and meaning itself. As we await further revelations, one haunting thought lingers. What if this is only the beginning? What if the universe is not silent, but alive with signals and structures and intelligences waiting to be found? The James Webb Space Telescope may have just cracked open a door that has been closed for eons. What lies beyond it could redefine everything we think we know about life, the cosmos,